Well, welcome back. We are starting Unit 2, Lesson 1, Units of Area, page 43 in your textbook. We'll have a couple definitions here in just a few minutes. But on page 43, it says formulas for perimeter and area. Look at the rectangles below. What does the perimeter mean? What does the area mean? So let's take a look at the definition of perimeter and the definition of area, and I would like you to copy this down in your notebook at this time. Perimeter, the distance around a figure. It is the total number of same size units of length required to form the sides without gaps or overlaps. Area is the amount of surface covered or enclosed by a figure. Area is measured by finding the number of same size units of area required to cover the shape without gaps or overlaps. So I would pause it and record both definitions, please. And then we will take a look at number 1 again. All right. Look at the rectangles below. What does the perimeter mean? What does the area mean? So down below, you have perimeter equals 16 centimeters. Let me move that out of the way. Area equals 12 centimeters squared. The question again is, what does perimeter mean? What does area mean? So in your black notebook, number 1, they want you to write up what each one means. If you look at the perimeter of this rectangle and the area of that rectangle, they're different. The perimeter is 16 centimeters, the area is 12 centimeters. When you're dealing with perimeter, it's plain units or centimeters. When you're dealing with area, it's always units squared. Length times width, centimeters squared. So for number 1 in your notebook, if you would write perimeter is the distance around an object, area is the amount of surface the object covers. So looking at these two problems here, you have 6 and the opposite side 6, opposite sides of rectangles that are same, and 2 and 2. So you have 6 plus 2 plus 6 plus 2 would equal your 16. Over here you have the length, 6 units, 1, 2, 3, 4, 5, 6, and it's centimeters, and then 2 units are 2 centimeters, and then area is length times width, 6 times 2, or if you were to count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's take a look at the next problem here. Whoops, too far back. All right, so for 2, 3, 4, 5, and 6, we have length and width, the units of centimeters, finding the perimeter, finding the area. So in the example here, you have 6 centimeters. Let's try that again. You have 6 centimeters and you have 2 centimeters. So you have the perimeter, you have 2 and 2 and 6 and 6 for a perimeter of 16. For the area, you would have 6 times 2, which equals 12. Area equals 12 centimeters squared. All right, let's take a look at number 2. So in your notebook, write number 2. So number 2, 4 centimeters and 3 centimeters, length and width. So for the perimeter, 4 plus 3 plus 4 plus 3 equals 4 plus 3 is 7. 4 plus 3 is 7. 7 plus 7 is 14. So your perimeter would be 14 centimeters. Length is 4. Width is 2. Oh, excuse me, 3. So you have 12 centimeters squared. Go ahead and complete 2, 3, 4, 5, and 6 exactly the same way. In your black notebook, please. All right, so number 2 we did. Again, whoops, move that out of the way. Number 3 now, you have 8 centimeters and 1 centimeter. So for perimeter, 8 plus 1 plus 8 plus 1 equals 18. So perimeter is 18 centimeters. And for area, it'd be length times width. 8 times 1 is 8 centimeters squared. Number 4, you have 4 centimeters, 5 centimeters. So it'd be 5 plus 5 plus 5 plus 5, which would be 20 centimeters. And then 5 times 5 would be 25 centimeters squared. Number 5, you have 10 centimeters and 4 centimeters. So we're talking 10 plus 4 plus 10 plus 4, 28 centimeters. 10 times 4 is 40 centimeters squared. Now for number 6, you have length times width. Oh, excuse me, you have length and width. And I'm not giving you the number. So it would be length plus width plus length plus width. Now, equals perimeter. Look close at this way of representing perimeter as well. 2 times the length plus 2 times the width equals the perimeter. Or you could even represent it this way. 2 parentheses length plus width, close the parentheses, equals the perimeter. So copy that down for number 6. Copy all 3 ways. And then for area, it's length times width equals area. Now again, it's L, W, and it's saying that whatever the length is, you multiply it by the width. Okay, you could also say L dot W as well equals the area. Let's just take a look at how this would look on grid paper. You don't have to copy this down, just pay attention at this part here. So if we had, let's see if that works. That's my rectangle. And if I were going to count the units, we have 1, 1, 1, 1, and 1. So you have 5 there. Opposite side, you'd have 5 again too. 1, 2, 3, 4, 5. And then you have 1, 1, and 1. Total of 3. So opposite would be 3 as well. 1, 2, 3. So your length is 5, your width is 3. So perimeter would equal 5 plus 3 plus 5 plus 3. So you'd have a total of 16. 16 units, because we're not, it doesn't state if it's centimeters or inches, so just plain 16 units. So the area then would be 5 times 3, length times width, which would be 15, and now because it's area, it's units squared, or you could say squared units, it'd be the same. All right, page 44 in your textbook. A perimeter and area of square. The figure at the right is a square. The length of one side of the square is given. Explain Y, you know the length of the other three sides of a square. So it wants you basically to define what it means to be a square. Number 8 says perimeter is a measure of distance around a figure. In the space at the right, show how addition can be used to find the perimeter of this square. In the space at the right, show how multiplication can be used to find the perimeter for number 9. And in number 10, discuss to calculate the area of a rectangle, we find the product of the measures of two of its adjacent sides. Why can this formula also be used to find the area of a square? So 7, 8, 9, and 10, let's take a look at those. In your black notebook, might be a good idea to put page 44. And then all the sides of a square have the same length. That's basically the definition. So write that down for number 7. Number 8, perimeter is a measure of the distance around a figure. So in the space at the right, show how addition can be used to find the perimeter of the square. So you know one side plus the other side plus the other side plus the other side gives you 304 centimeters. So the perimeter would be 304 centimeters. Now, number 9 says in the space at the right, show how multiplication can be used to find the perimeter. Because all four sides are the same, for a square, all same length, you could just take 76 times 4, which would give you the 304 centimeters. So for 7, 8, and 9, please copy exactly what I highlighted down in your black notebook. And then let's take a look at number 10 now. To calculate the area of a rectangle, we find the product of the measures of two of its adjacent sides. Why can this formula also be used to find the area of a square? So again, it's saying, to find the area of a rectangle, you find the product of the measures of the two adjacent angles. So you have this side and that side, and you find the product of those two adjacent angles. So 76, in this case, 76, because it's a square. So it's saying the formula for area of a rectangle is really, could be used really to find the area of a square. That's all it's saying. You don't have to actually copy number 10 down, but that's what it's saying. Adjacent angles. Oh, adjacent sides, I should say. This is this side and that side. All right, let's take a look at 11 here. On 11, it says, in the space at the right, calculate the area of the square, then write a formula for the area of a square. So let's just move on here. In the space at the right, calculate the area of the square, then write a formula for the area of a square. So the area would be 76 times 76. So we'll go ahead and solve that problem by writing 76 times 76 for a grand total of 5,776 centimeters squared. Formula for area of a square could be side times side. Again, the dot representing the multiplication symbol. Okay, so number 11, you should have not only the actual multiplication problem, but then this formula. Number 12 says, how does... All right, let's take a look at number 12 here. How does doubling each dimension of a rectangle that is not a square affect the perimeter and the area of that rectangle? Give an example to support your answer. Doubling the dimensions of a rectangle that is not a square affect the perimeter and the area of that rectangle. Give an example to support your answer. So if you started out with a rectangle, and let's just say that the rectangle was, let's just keep it simple, 2 and 1. Okay, and now you doubled it. So now you have your rectangle. And now the rectangle is doubled. So now we have 4 and 2. What would be your perimeter here? And your area. and your perimeter here, and your area. Well, 2 plus 1 plus 2 plus 1. So we have 4, 5, and 6 units, and area would be 2. Here you have 4 and 2, so you have 4 plus 2 plus 4 plus 2, you have 8, and 2 is 10 and 12. And in your area would be 8. So perimeter 6, area is 2, perimeter 12, area 8. All right, so it says, how would that affect the perimeter and the area of the rectangle? Give an example to support your answer. So the perimeter doubles and the area quadruples. And if you go back, you can see the perimeter doubles, 2 to 4. Area quadruples, went from 2 to 8. So here's your example for number 12. And your write-up looks like this. So go ahead and pause it. The perimeter doubles and the area quadruples. Let's go ahead and just look at number 13, but we don't have to solve it, or we don't have to write it down. How does doubling each dimension of a square affect the perimeter and the area of that square? Give an example to support your answer. So if you were going to now double the dimensions of a square, okay, how would that affect the area and how that would that of that square? The perimeter doubles and the area quadruples. All right, page 45. We have a question from Puzzle Penguin. What's the error? Dear math students, today I went to the paint store to buy paint for my dining room ceiling. My ceiling is a rectangle, 12 feet long, and 10 feet wide. I told the clerk that I needed enough paint to cover 120 feet. He told me that I'd made a mistake. Can you tell me what I did wrong? Your friend, the Puzzle Penguin. All right, so he wants to paint the ceiling. I want to paint the dining room ceiling, and he said he needs 120 feet. He told me, the guy at the store told me that I made a mistake. Can you tell me what I did wrong? Write a response to Puzzle Penguin. Well, okay, let's see. We have 12 feet by 10 feet. Now, if I was finding area, area equals the length times the width. So in this case, it'd be 12 times 10, which does equal 120, should be feet squared. But now, if you look at the problem closer, it's saying how much paint for the ceiling. Okay, so the ceiling is just one of your rectangular room, one side, the top. So by taking 12 times 10, you would be finding the area of the ceiling. And that's all you would be painting, is what I guess I was trying to get at there. But the mistake was that he said 120 feet, and it should be 120 feet squared. So for your Puzzled Penguin response, write back that 120 square feet, not 100 squared, not 120 feet. Area is always given in square units. So for number 14, go ahead and jot down basically he needed enough paint to cover 120 square feet, not 120 feet. Area is always given in square units. We're going to skip over 15 and move right into lesson, or problem number 16, excuse me, on page 46. All right, find the side length or area of each rectangle or square. So here we have number 16. So go ahead and actually draw the actual square there. I'll highlight it. So number 16, and it wants you to find the area, and it's a square. So it's length times width, side times side, 6 times 6. In this case, 6 times 6, 36 feet squared, or squared feet, however you want to write it. Number 17, go ahead and work this one. It's giving you the area of 25 inches squared. It's telling you that this side, S, and this, I think that's an S, or maybe that's a 5. I think it's an S still, are the same because it's a square. Okay? So to get 25, knowing that your shape is a square and all sides are equal, you'd have to look for a number that multiplied by itself would give you 25, and that would be 5. So 5 inches would be your answer for number 17. All right. And then you would work the others pretty much the same way. I think 16 and 17 is plenty. So let's move on. The answers here, 36 feet squared and 5 inches for number 17. Let's just look at number 25 here on this page. Stephen drew a picture of his sister that is 8 centimeters long and 5 centimeters wide. He wants to make a frame out of colored tape to put around the picture. How much tape will he need? So here's his sister, 8 centimeters long and 5 centimeters wide. So I'm just going to jot that down. 8 and 5. He wants to make a frame out of colored tape to put around the picture. How much tape will he need? So, are we needing area or are we needing perimeter for this problem, number 22? So, you're to put a frame around it, you're walking around it, so you're walking around, you have 5 and 8 and 5 and 8. So for number 22, you're really needing the perimeter. And to find the perimeter, you would add the 8 plus the 5 plus the 8 plus the 5. And because it's perimeter, it's just plain centimeters. All right. All right, let's move on. Lesson 2, area of any right triangle. This is on page 47. So go ahead and draw a line in your black notebook and write down lesson 2, page 47, area of any right triangle. And then let's look at page 47, perimeter and area of a right triangle. What is the area of the rectangle shown here on the right? So the area of this rectangle, length times width, 6 times 3. So for number 1 on page 47, would you please write area equals 6 centimeters times 3 centimeters equals 18, dealing with area, so it's centimeters squared or squared centimeters. All right, now it says draw a diagonal line and make 2 triangles. What is the area of each triangle? Why do you think so? So a diagonal line, if I were going to make a triangle right here, and here's my one triangle, and number 2. All right, so area of the whole rectangle was 6 times 3, 18 centimeters squared. Now we made 2 triangles. The formula, number 2, for area of a triangle is 1/2 the base times the height. And we will have a couple vocabulary words here, height and base. So if you look at the rectangle here, you have a base of 6, and the actual triangle has a height of 3. And then the formula is 1/2 the base times the height, because 6 times 3 is 18. That's the area of the whole rectangle. But the triangle is half of the rectangle. So your formula is 1/2, and go ahead and copy this down, equals 1/2 base times height, which is 1/2 of 6 times 3, which would be 9. So 9 centimeters squared would be the area of the triangle. The whole area of the rectangle has been divided in half into 2 triangles. So write that up for number 2. And that formula there is important. 1/2 base times height. All right, for number 3, you don't have to copy this down, but we'll just take a look at it. It says, what do you notice about the 2 yellow triangles at the right? So if you look at these 2 triangles right here and right there, one triangle fits on top of the other triangle. They have equal areas because of that. And then let's look at number 4 here as well. I'm just going to pull this down. I think I can, or maybe I pull that all the way down. How does the areas of the rectangle and the large right triangles compare? Explain your reasoning. They are equal. Both share the same area plus the area of one of the small triangles with equal areas. All right, so take a look again what it's talking about. How does the area of the rectangle and the large right triangle compare? Okay, the large right triangle, okay, both share the same area plus the area of one of the small triangles with equal areas. Take a look at that. Okay, you don't have to copy number 5 down, but let's take a look at it. It says, write and use a formula to find the area of the rectangle or the large right triangle. Again, area, 1/2 the height times the base times height, same thing. 1/2 times 4 times 3, which would equal 2 times 3, which would equal 6 centimeters squared. Number 6 says, do the rectangle and large triangles at the right have the same areas? Explain how you know. So if you look at the area right here and the area right there, and then you look at the large rectangle, it says, yes, they do. The small triangle at the top of the rectangle has the same area as the small triangle in the left part of the large triangle. So if you look at it here too, here's another. If you take this, okay, and then if you also do this, they're all the same. This one, that one, that one, that one, and that one. All right, let's look at number 7 here. Write and use a formula to find the area of a large right triangle to the right. So here you have the area would be 1/2 base times height, which would equal 3 times 4, which would equal 12 centimeters squared. All right, let's move on. So we have a triangle. This is on page 48. A triangle with a right angle, square corner, is called a right triangle. The area of any right triangle is half the area of a rectangle with the same base and height, or the same area as a rectangle with half the base or height. These rectangles are called related rectangles. So what is the area of each right triangle shown below? So if you look at number 8, what is the area of each right triangle shown below? Now here's another way of determining a right triangle. This symbol right here in the corner, that's telling you that it's a 90-degree angle. 90-degree angle is a right angle, and a right triangle in this case. So if you were going to find what is the area of each right triangle shown below, the area would be 1/2 the base times the height of the full rectangle. So 1/2 the base times the height, which the base 4 centimeters and the height 5 centimeters. 4 times 5 is 20. Half of that would be 10. So the triangle would have an area of 10 centimeters. Okay? Now, number 9, look what it's showing you here. Here's the dotted line. But if you were to take this triangle and move it over there, then you would have, which is a right triangle, then you would have your square or rectangle that you would be needing to solve the problem. Okay? So let's take a look at 8. Hopefully you copied it down in your notebook already. I'm just going to move ahead here. So here's your 10 centimeters. Now here, if you look, 8 would be your base. 3 would be your height. 8 times 3 is 24, but you have to take 1/2, which would be the 12 centimeters squared. Okay, so copy number 9 down. Number 10, again, look, if you were to take this right triangle, make it a rectangle here, the top part, the triangle right here, move it down there, you'd make that rectangle, which would be you would have from here to here a 4, and then you would have here to here, which would be 2, and then you have 8 centimeters squared. Another way of looking at that too. Or 4 times 4, which is 16, and half of 16 is 8. 1/2 the base times the height. Centimeters squared. So, right triangle, a triangle with one right angle, a right angle has a measure that is equal to 90 degrees. So, all you need to do here is write down right triangle and then give me this example right there. Related triangles, a rectangle with the same base and height as its related parallelogram. A rectangle with the same base and height or half the height or base of its related triangle. So write down, if you would, related triangle, and then let's just draw these two right here. Same base, half the height. Okay, same base, half the height, same height, but half the base. Okay, so they would be considered related. One same base, but it has half the height from here to here. This one has the same height here to here, but then it has half the base here to here, or here to here. So copy those two examples down, please. And then let's look at this page. It says number 11, to show that a triangle is a right triangle, mark the right angle with a small box. Find the area of each right triangle below. So the right angle for number 11, let's go ahead and copy this down, would be right here. Area would be 1/2 the base times the height. So 4 times 3 is 12. Half of 12 is 6 centimeters squared. And again, if I were to draw, oops, that's a very good job here. There's my triangle, making my rectangular square. Okay, and this one here, and we'll just do one more. Right here would be the right triangle, be 1/2 of 6 times 6. 1/2 of 6 times 6. Well, 6 times 6 is 36. Half of 36 is 13 centimeters squared. All right. I was just joking with you. 36, half of 36 is 18. So this should not be 13. This should be 18. I'm glad you caught that. All right, we are going to skip over the next problems. I think hopefully by now you have a pretty good understanding of area of right triangles. Tomorrow in class we will work on lesson 1 and lesson 2.